label for Kefsol. Kefsol is the trade name, and you know it's a trade name because here's the registered trademark, and that means it is owned, proprietary ownership of Eli Lilly. Lilly is a big drug company. Kefsol is an antibiotic, rather potent one actually, and this is a trade name for sterile cefazolin sodium USP. So the generic name is cefazolin USP, and you know it's generic because it ends in United States Pharmacopoeia. It is 500 milligrams of cefazolin, and cefazolin, again, it comes in powdered form. This is the NDC, the National Drug Code, where you could research that information on the FDA website. So it's a registered trademark, and this RX means that it cannot be sold other than through a physician's or provider prescription. Here's some information. Law prohibits dispensing without prescription, and it says for IM or IV use. Dosage, see literature. To prepare solution, add 2 milliliters sterile water for injection or 0.9% sodium chloride injection. Provides approximate volume of 2.2 milliliters. So you add 2 milliliters and you get 2.2 milliliters of medication. And here's something important. 225 milligrams per milliliter. That means after reconstitution, for every milliliter, there's 225 milligrams. Shake well, protect from light, and here's some information about storage before it is reconstituted. After reconstitution, it's very, very short shelf life. It says store in a refrigerator, and for storage time, see accompanying literature, but if it's kept at room temperature, you must use within 24 hours. So we have some information here, and it asks, when reconstituted according to label directions, how much Kefsol medication is in each milliliter? And we know this because there is 225 milligrams per milliliter. So I'm going to write 225 milligrams in each milliliter. All right, and now we have an order. It says the provider orders Kefsol, 325 milligrams IM stat, which means immediate. After reconstitution, according to the directions, how much will the nurse draw up into the syringe for this patient? So we will start by knowing that drawing something up in the syringe, we know that it's going to be milliliters. So our unit of measure that we are looking for is milliliter. That's our unit of measure. Okay, we're going to draw an equal sign. We're going to draw a line which will indicate that there's going to be a numerator and a denominator as we figure this out using dimensional analysis. Instantly we know that because our unit of measure is milliliter, that milliliter must be our unit in the numerator. So what do we have that we know that talks about milliliters? Well, we know that there's 225 milligrams in each milliliter, right? So 1 milliliter is 225 milligrams. We're going to draw a multiplication sign, another line. Because we have another fraction, we're going to have a numerator and a denominator. In the numerator, it must be milligrams. Our unit must be milligrams. We know this because we're crossing, we're going up the hill. So milligram, what do we have that we know about for milligrams? Well, we know that the doctor has ordered Kefsol 325 milligrams. So 325 milligrams goes in the numerator. 1, which is our placeholder, goes in the denominator. And are we ready to figure this out? Well, we are, because our milligrams will cross out, and the only thing that we have left is milliliter, which is our unit of measure that we're trying to find. So our equal sign, we multiply the numerators together. 1 times 325 is 325. 225 times 1 is 225. and 325 divided by 225, and that equals 1.44. We are going to round to the nearest tenth, and we know that when we do, we first look at the hundredth spot. If that is 5 or greater, it bumps up the next, the left side. So it's not greater than or equal to 5, it's a 4. So our answer is 1.4 what? 1.4 milliliters. Here is a drug label for ceftriaxone for injection USP. That is a generic name, and you know it's generic because it ends in USP, United States Pharmacopoeia. So this is a generic name. It is 1 gram for IM or IV use, RX only, which means you must have a provider prescription. You can't just sell it over the counter. Single-use vial. You cannot use it more than one time. Each vial contains sterile ceftriaxone, sodium USP. So here's some additional information in addition to the National Drug Code number, and the National Drug Code number signifies that which we can find it on the FDA's website. And we have, for IM administration, reconstitute, because this is a dry powder, so reconstitute with 2.1 milliliters, 1% lidocaine hydrochloride injection, USP, or sterile water for injection, USP. Each 1 milliliter of solution contains approximately 350 milligrams equivalent of ceftriaxone. That's a very important piece of information. Each 1 milliliter, after it's reconstituted, will contain 350 milligrams of ceftriaxone. For IV administration, see package insert. Usual dosage, see package insert. Storage prior to reconstitution, pretty good shelf life, and there will be a lot number and expiration date on this label. After reconstitution, see package insert. Protect from light. So we have a good deal of information on this. It comes in a dry powdered form, and it must be reconstituted with a liquid in order to administer to our patient. When reconstituted according to label directions, how much ceftriaxone medication is in each milliliter? In other words, what is the concentration per milliliter? So we have information here. Each 1 milliliter solution contains approximately 350 milligrams ceftriaxone. So we're going to write 350 milligrams here per milliliter. All right, and we have some information about a doctor's order. The provider has ordered ceftriaxone 300 milligrams IM stat, which means right now, immediate, after reconstitution according to the label's directions. How much will the nurse draw up into the syringe for this patient? Well, we instantly know that if we're drawing something up into a syringe, it's going to be milliliters. So our unit of measure, in other words, what we are trying to find, what information we are trying to find, will be milliliters, which is our unit of measure. So milliliters, we're going to put our little equal sign there. And we draw a line so that we have the image here, knowing that there's going to be a numerator and a denominator. Immediately before we do anything, we know that with dimensional analysis, the numerator of that first fraction must be the unit in the same unit as the unit of measure that we're looking for. So it's going to be milliliter. I know that before I start and do anything. So what do we have in terms of information about milliliter? Well, we know that there's 1 milliliter. For every milliliter, there's 350 milligrams. I'm going to write 1 milliliter, 350 milligrams. I'm going to draw my multiplication sign, make a line. We now have a second fraction where we can have a numerator and denominator. In the numerator, we know it's going to be milligrams because we climb the hill and we cross over going up. Milligrams is on the denominator. On the left, it'll be in the numerator on the right. What do we have for information on milligrams? Well, the doctor has ordered, the provider has ordered 300 milligrams right now, give it now. Okay, so I'm going to write 300 milligrams is to a placeholder here. Are we ready to solve? We are. And we know we are because we can cross out milligrams. They cross. And the only thing left is milliliters. Milliliters is our unit of measure. That's what we're trying to find out. And so we're ready. Multiply the numerators together. 1 times 300 is 300. Multiply the denominators together, and 1 times 350 is 350. So 300 divided by 350, and what does that equal? It equals 0.857. Now we're going to round to the nearest tenth, which means we look at the hundredth. When we round, we look at the hundredth spot. If it's 5 or greater, the 10th spot will bump up. So it is 5 or greater, so this becomes 0.9. 0.9 what? 0.9 milliliters.